beginning. So for the first one, all this is defining that very first theorem that told us that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle, and they're also similar to each other. So what happens when we have our original right triangle, and when I draw in an altitude, it then creates two smaller triangles, and then all three of the triangles are similar. On the quiz, you will have to write a similarity statement, which is just like question number 2. So if it helps you to pull them apart, then pull them apart. So for example, I'm going to pull them apart just so you can see that it's easier to find the matching or the corresponding proportional sides. So my original one, I'm going to go ahead and outline here in black. It's the original right triangle. So right here, I'm going to try to face them all in the same orientation. So I have H down here with the right angle. This is the original right angle. And then I have F and then G. Once we draw in this altitude, HE, it now creates two smaller right triangles. I have a little one over here to the left, and then I've got like a medium-sized one over here to the right. Now I'm going to flip them over so that way they're both facing the same way as the original, because the right angle on both of these is now down here at E. It's no longer at H. So when I flip them around, the blue one is F and then E with the right angle and then the H. Then the red one, again, it's got the right angle at E, and then it's got G and then H. Now, what I've done here, the way that I positioned them, these are all the hypotenuses. The FG, notice they're all across from the right angle. And the similarity statement that they're asking us to write, they started it out for us. This is actually the blue triangle. Notice they went from the hypotenuse over to the shorter leg out of the two. So if you look at it, this FE here, see how this is the shorter leg of the blue one? And this is the longer leg, and this is the hypotenuse. Then if you do it on the red one, the shorter leg of the red one, which is this leg here, which is really the longer leg in the blue one. And then the hypotenuse is here, and the longer leg is here. So let me go ahead and label. So over here, this is the shorter leg, longer, shorter leg, longer. So I sat them all the same way. So then when I go to write my similarity statement, I'm starting with the blue one, H, F, E. It went from the hypotenuse to the right angle via the shorter side, or the shorter leg. Then for the black one, hypotenuse to the shorter leg. So then you would write is similar to G, F, H. And then do the same thing on the red. Hypotenuse to shorter leg. So G, H, E. So it might help some of you if you pull it apart. You don't have to, you could just match which one's the shorter leg on all of them, which one's the longer leg, and go from there. So that's what you're going to have to do on the quiz, is you will write, instead of how they did in the homework, you're going to just write the three triangles all together here. For this homework, numbers 3 and 4, the next two questions, you did not have to use the proportions that were in the notes. you had to use your prior knowledge from chapter 8 and use the fact that these are similar triangles, and then write the proportional sides. So you don't have to redraw all 3 triangles. Just pick 2, match legs, match hypotenuses, whatever you want to put in your proportion. So for this one, if I zoom on in here, I'm going to go ahead and use the original, which is going to be the XYZ here. Let me do it in black, XYZ. So let me pull it over here to the side. And the right angle is here. Now I'm going to do, instead of the little blue one, I'm going to do the red one. Again, it doesn't matter because all 3 are similar. So now I'm going to pull this one out, and I'm going to flip it upside down so that the right angle is in the same spot as the Z. Notice the right angle now is at the W. So for this one, and I'll put the Z here, and then the X, and I'm going to add in these numbers now. Now the original big one had all 3 sides, 7, 25, 24. The red one, the WZ was X, and the XZ is the hypotenuse. It's the 24. So now what I'm going to do is I'm going to match the 2 legs and the 2 hypotenuses together to find the value of X. So for this one, what I can do here is I can match my 2 sides. So I'm going to match the 2 hypotenuses. And let's see. So I'm going to match the WZ. So this is red. WZ. These are 2 legs. And I'm going to match it with the YZ. And then I'm going to put those numbers in. So the WZ was X and the YZ was 7. Then now I'm going to do the 2 hypotenuses. And the hypotenuse from the red one, that one's going to be the XZ. And then over XY. And that's black. So hypotenuse of red was 24. Hypotenuse of the black one is 25. So again, you're using your chapter 8 knowledge. This is the proportion that I'm going to solve. So I match the 2 legs. And again, you could have done the smaller blue one. It doesn't matter which 2 triangles you pull out because all the sides are proportional because all 3 triangles are similar. So now I'm going to go ahead and cross multiply. Notice it said exact. So I'm going to do 25 times X, 7 times 24. 7 times 24 is 168. I'm now going to divide both sides by 25. Now, you could have either left it as 168 over 25, or you could have divided it because 25, when you divide that into 168, it'll be a decimal, but you get a remainder of 0. It's not a crazy decimal that goes on forever. So you could have either entered either way on this one. They're both exact. Now, on the quiz, you're going to use the formulas that were on the notes. So the 2 proportions that were in the notes, that's what you're going to be using on the quiz. That's what I put in tonight's homework, okay, to reinforce it. But again, on the test, I may give you a question like this where you have to apply your chapter 8 knowledge. But on the quiz, I'm going to test you more on the knowledge just learned in this lesson, which was geometric means. So let's try number 4.
Oh, wait, miss.
Yes. So for number 4, I'm going to pull them apart again as well. I have the original black one. And I'm going to pull out the red one again as well. So this one. So again, let me put them in the same, so they face the same way, so it's a little bit easier to see. Actually, well, I can draw the red one like that. And then the bigger one in black. Right angle, right angle. So for the larger one, that is going to be, the right angle is at G, F, E, 39, 15, 36. And then for the red one, this one is, H is the right angle now, and G and E. And then GE is 36, and GH is X. So I'm going to do the same thing. I'm going to match legs, and I'm going to match hypotenuses. So for this one, I'm going to match my two hypotenuses, my two legs together, just like I did on the other one. So I'm going to put the two legs. So the leg of the red one is GH. The leg of the black one is the FG. I'm going to do X over 15. And then I'm going to put the two hypotenuses together. So then the two hypotenuses, they're going to be the EF and the EG. So EG, this is from the red, over EF. And again, let's put it in. And 39 over 36. And now I'm going to cross multiply. So this is the proportion I'm solving. And I get 39. Now, if you weren't using a calculator, you might want to reduce 36 over 39. But if you're afraid that you're going to reduce the wrong way, keep it as it is. So I'm going to get 39x is equal to 15 times 36. Cross multiply, yes. Whenever it's an equal sign in between the two fractions, you're always doing the cross products, the cross multiplication. If it were a multiplication sign or a dot in between, that's when you would have done top times top, bottom times bottom. So 15 times 36 is 540. Divide by 39. And divide by 39. And we get x equals 540 over 39. We can actually reduce this. I can divide them both by 3. And then it becomes 180 over 3, which would be an acceptable answer. Or we can divide it, and it said to the nearest hundredth. So if I divide 180 by 3, by 13, sorry, by 13, 180 divided by 13, that's going to give me 13.846153, rounded to the hundreds place. 4 looks at the 6, so 13.85. So either that or that would be your answer. Now, on the quiz, you're going to get some type of real life situation like this. This will be the only question that you'll round to the tens place. All the other ones will be in simplest radical form, or they're going to be integers. So for this one, I'm doing exactly the same thing. I've got my original blue triangle. So let me maybe outline it a little bit more. So this is the original blue. Maybe I'll do it in purple so you can see it better. So we've got the original, and it's in purple here. And then we're going to compare it to a smaller triangle here. Let's do again, this one. So I'm going to put the two legs together. So I have a leg here of the green one is X. The leg of the original one is the 12.8. And then I'm going to take the two hypotenuses. So the hypotenuse of the new one, the original one is the 26.3, and the hypotenuse of the green one is the 23. So I'm going to do 23 over 26.3. So again, these were legs. These were the two hypotenuses. Again, I'm going to cross multiply, and then I'm going to round my answer to the nearest tenth. So I'm going to get 26.3x is equal to 12.8 times 23. So once I multiply 12.8 times 23, I get 294.4. Divide by 26.3, and x is equal to 11.193916, rounded to the tenths place. The 1 looks at the 9, and it tells it to go to 11.2. Geometric mean questions. You will be leaving these questions that are on the quiz in simplest radical form. So whenever you're going to do the geometric mean of two numbers, you're going to take them, you're going to multiply them, and you're going to square root the product. Now, if when you multiply this and then you hit your square root button, if this were to have given you a crazy long decimal, then you would know, wait a minute, I can't leave my answer like that. I got to go back to the beginning and do a factor tree. This one was a perfect square. So this answer in simplest radical form is just an integer, and it's 16. For the next one, this one will be left in simplest radical form because 14 times 20, once I multiply this, I get 280. Once you square root that, you get this number, 16.7332. Once I square root this, notice it is not an integer. This is a clue that, nope, that's the wrong answer. I need to go back and I need to do a factor tree. You can either choose to find factors of 280 or just go back to the beginning. Let's do a factor tree, and we've already got two factors of 280, 14 times 20. So start doing until it's prime. 2 times 7, 4 times 5, this one's prime, and now finally I have all my prime factors. Now we go back and look for pairs. I have a pair of 2s is the only pair I can make. Only that 2 comes out. Anything else that doesn't pair up, you have to multiply back together. So 7 times 5 times 2 is 70. So final answer here is 2 square root 70. Next. Yes. Same thing, geometric mean. Now, as soon as you're asked to find geometric mean of two perfect squares, this should be a clue that the answer is going to be an integer. So you can do this two ways. You can either, because you're using a calculator, go ahead and just multiply this, get 400, hit that square root button, and the answer is 20. If you weren't using a calculator, what you could do is square root these individually or do the factor tree. Square root of 16 is 4. 25 is 5, multiply them, and you still get the same answer. So you could do it either way. Now, the next one, 17 is not a perfect square. So again, that should be a clue that you're going to have a radical in your answer. So 17 times 36. If you wanted to try to multiply it, just to see if maybe something paired up with the other number, this is 612. Once you hit that button, you get 24.738633. Soon as you see that, know that, wait, I got to go back. I need to do a factor tree. And again, just use the original two numbers. So you would do 17 times 36, 17's prime, 36 isn't. Now, if you realized it was a perfect square, you could have already stopped, or as soon as you see you have a pair of numbers, take that pair out and leave the unpaired number behind. Or if you didn't recognize that, go all the way to prime. So you would have just kept on going, 17, 6 and 6, 2 times 3, 2 times 3, and now look for pairs. So I got a pair of 2s, a 2 comes out. I got a pair of 3s, a 3 comes out. 17 did not pair, leave it behind. And then everything that came out, multiply back together and leave the 17 underneath. Same answer either way. Good there? Yes. We're going to go ahead and for this first one, we are using the geometric means altitude theorem. And that theorem states that we would take segment 1, which is the 4, over this x, which is the altitude, equals the altitude over segment 2. So let's try to apply this geometric means altitude theorem. Okay, so segment 1 was 4. The altitude I do not know. It's the variable x. And segment 2 is 16. I'm going to do the cross products here. X times x is x squared. 4 times 16 gives me 64. Square root both sides. And x equals 8. So my altitude is 8. Number 11, I'm using exactly the same proportion. Segment 1 over altitude, altitude over segment 2. So let me go on to number 11. So number 11, again, segment 1 is going to be the 12. Segment 2 is going to be the y. This time my altitude has a number. It's 18. Now, you can switch up segment 1 and 2. It doesn't matter because, again, you're just multiplying them. So let's fill it in. So segment 1 over the altitude, altitude over segment 2. No square root here. All we're doing is multiplying and dividing. So we're going to do 12 times y is equal to 18 times 18. 18 times 18 gives me 324 equals 12y. Divide both sides by 12 and y equals 27. Now, if you wanted to, you could have reduced 12 over 18 and made it 2/3. But if you do that, just be careful if you're simplifying mentally. Again, you're using a calculator. If this quiz would have been non-calculator, I would have highly recommended you reduce that first. The next one, this is where we're going to use the other proportion, the geometric means length theorem. And this one is the hypotenuse. And in this picture, the original hypotenuse of the original right triangle is 4 plus 5. It's 9. And then I'm going to do it over leg. And then leg over the SOHAL. And in this case, our SOHAL is going to be segment 1. Because it is the segment of the hypotenuse. So the piece of the hypotenuse that is adjacent, or in other words, next to the leg. So let's fill in the numbers.
Wait, so segment 1 is where?
Segment 1 is the 4. Or I'm sorry, the 5.
And then segment 2 is 4.
Correct. And we don't need that because we're not finding the other leg. We just needed the 4 to get the length of the hypotenuse. Yes. Yes.
The leg is X.
The leg is X. Okay. The leg is X. So this is the leg. This is the Sohal, which is also segment 1. And then the hypotenuse we found by adding 4 and 5. So let's fill in. Hypotenuse is 9. The leg is X. And the segment of the hypotenuse adjacent to the leg is 5. I'm now going to cross multiply. X times X gives me X squared. 9 times 5 is 45. Now, if I square root this, the square root of 45 is going to be X is equal to 6.7082039. Do not tell me that is the answer. Go back and do a factor tree. So the square root of 45, break it down to the two numbers you just multiplied, 9 and 5. Factor tree. Make a pair of 3s. A 3 comes out. No pair for the 5. Leave it underneath. So X is equal to 3 square root 5. Same formula. We're going to be doing hypotenuse, which is Z. The leg, which is 27. The Sohal, or segment 1, is going to be 16. So let's fill it in. So I have, it's going to be leg, leg, and then Sohal. So hypotenuse is Z. Leg is a number this time. It's 27. The segment of that hypotenuse that's adjacent to that leg, so the one right next to it, is the 16. Going to cross multiply. 16 times Z. 27 times 27 is 729. Divide by 16. And Z is equal to 729 over 16. This would be exact. If you divide this, you also get an exact decimal. It's 45.5625. So either answer here, because you would get a remainder of 0. If you only put 45.5, it would mark it wrong. Or 45.6. You would have to put all of those numbers.
We have a question. How come, like, in number 12, you put the factor tree, but in number 13, you didn't? You kept that as a decimal?
Because I'm not solving for a square root. So whenever you have a variable that's squared, that's when I want simplest radical form. If it's just a variable like X, Y, or Z without a square on it, then you could put the decimal or the fraction. Everybody understand what she just asked? Whenever it's something like, let's say it was Z squared equals 125, this is where I want simplest radical form, when you're solving for a variable squared. But if it's just Z equals something like 180 over 3, then you can leave it like that or divide it. But if it's got a square on it, simplest radical form.
Wait, why did you have to put all the numbers after the decimal?
Because that is the exact answer. Because if you do the division by hand, you would get a remainder of 0.
Also, how do you know if you use the Sohal? Because I didn't do that.
Whenever you're looking for a leg. If you're looking for an altitude, you don't. Now, technically here, we could do some Pythagorean theorem work. Like, remember, these are similar triangles. So we could actually have found this piece. Then we could have done 16 minus Z, and then found that piece that way. There's different ways you could go about this. But that was the most direct route, by using that proportion.
The triangles are always going
Correct.
And also, like, I don't really know how to do this at all.
The SOHAL is just the SOHAL stands for the segment of the hypotenuse. So remember, the hypotenuse of the original triangle gets broken into two pieces. So we have segment 1 here, and then we have segment 2, because here's our original right angle here. And then across from that right angle, this is the hypotenuse. And that original hypotenuse gets split into two little pieces called segment 1, segment 2. Then the segment of the hypotenuse that is adjacent to the leg, that's the AL, adjacent to the leg, the piece of the hypotenuse that's right next to that leg. This is another leg over here, and its SOHAL would be segment 2. So it's the piece of the hypotenuse that's right next or right around the corner of that leg. Does that make sense?
Yeah.
Pretty good so far.
And then that's just the formula you use?
Yes, you just memorize this one.
I have a question.
Yes.
Why did you do this Z over 27? Why? Like,
Why?
yeah.
Because the leg in the picture was 27 and the hypotenuse was Z. That's why you got to label your picture. So what we're trying to label here, when we're labeling hypotenuse and leg, we're labeling the original triangle, the legs and the hypotenuse. Then remember, your altitude is drawn in here, but we're not labeling the legs and the hypotenuse of the new triangles, only the original. Does that make sense?
Yeah.
Okay. All right, next one, number 14. This one we're going back because we have the two segments and we have an altitude. So we're going back to the other proportion. So the 12 is my altitude. A plus 5 is segment 1. 18 is segment 2. Because again, here is my original triangle. And this is my right angle here of the original. So my hypotenuse is over here. So the proportion I'm using, again, is segment 1 over altitude, altitude over segment 2. So let's fill in the pieces. So segment 1 is A plus 5. My altitude is 12. My segment 2 is 18. Now, we need to do the cross products. Again, if you weren't using a calculator here, I would simplify the 12 over 18 and make it 2/3. But let's just use it the way it is. So I'm doing 18 times A plus 5 is equal to 12 times 12. 18 times A, 18 times 5, 12 times 12. Subtract 90. 18A is equal to 54. Divide by 18, and A equals 3. $15. Okay, this is something similar to what we saw in the notes, where we had to find all of the pieces that had variables.
What was the answer for number 14?
So Z is a leg. Y is the other leg. And then the hypotenuse is over here. It's going to be the x plus 16. Now, I'm going to figure out what the hypotenuse is. After I find out x, then I can add it to 16. Now, I also need to realize that my hypotenuse was split up into segment 1. Segment 2 is the x. And then the 12 is the altitude of the triangle. I'm going to be using both proportions. I'm going to be doing the geometric means altitude theorem first. So I'm going to go ahead and set this up. I'm doing segment 1 over altitude equals altitude over segment 2. That's the first proportion I'm going to use. And then the other one, I'm just going to write it all here, the leg, because it's going to change. I'm going to do 2. I'm going to do 1 in purple, 1 in pink. So hypotenuse over leg, leg over the Sohal. So let's do the first one. So segment 1 is 16. The altitude is 12. Segment 2, I don't know. So again, if you weren't using a calculator, you might want to simplify 16 over 12. But I'm going to go ahead and just cross multiply. 16 times x, 12 times 12. Divide both sides by 16. And x equals 9. Now that I have segment 2, which is 9, I can find the hypotenuse by doing 9 plus 16, and the hypotenuse has a length of 25. Now I have to use this proportion 2 times. 1 in pink, 1 in purple. By dividing 144 by 16. All right, so hypotenuse is 12. Oh, sorry, 25. I'm going to do a purple leg, which is the y. And it's Sohal, the segment of the hypotenuse that it's adjacent to is this segment 2. It's the 9. It's the piece of the hypotenuse right next to that leg. So I'm going to put 9 here. Cross multiply, y squared, 25 times 9 gives me 225. Square root it, and it's 15. Perfect. Now I'm going to do the pink one. So still hypotenuse, it's still 25, but this time the pink leg is z. And the Sohal for the pink leg is the 16. It's the segment of the hypotenuse that is right next to that leg. So I'll put 16 here. And then I do z squared equals 400, square root it, and z equals 20. We have 2 more. And again, we're just using the similar triangles for number 16. Once you figure out the 3 triangles match the sides. So you could show the proportional legs, the proportional hypotenuses. So this had 2 answers here, dB over dC, and then dA over dB, and then dB over BC, and dA over BA. And then the last one, it was a bit challenging. You will not have anything this difficult on your test or quiz. However, AC wasn't that bad. AC, if you just treat this as one big right triangle, AC is just the hypotenuse. So you could just do 15 squared plus 20 squared equals the AC squared. It's the hypotenuse. All I'm doing is A squared plus B squared equals C squared. So 225 plus 400 equals AC squared. 625, and then square root it, and that's 25. Now what I can do is use that side, that 25, to find this altitude, which I could call x. So what I need to do is figure out what the 2 segments are. I need to figure out segment 1 and segment 2. Well, I know AD here is really made up, let's see, AD is the blue one. So AD is really made up of 20 squared is equal to AD times AC. And if I know that 20 squared is 400, and I just found AC, I could put 25 here. And then to find AD, sorry, this is AD, divide by 25. And then I find out that AD, 400 divided by 25, is going to give me 16. That's the length of AD. So if this is 16, and I already knew the whole thing was supposed to be 25, I could just do 25 minus 16 and get this piece to be 9. And now I can do my proportion. I can do segment 1 over x, x over 9, x squared equals 225. I'm sorry, 144. And then square root it. And x, which was my altitude, which was BD, is 12. So that is it. Again, you won't have anything that complicated where I give you all 3 hypotenuses or find one of them.